Yeah, so this is basically a continuation from last Friday. We were not able to finish because of time, but we pick up exactly where we stopped. And yeah, we're going to look at how to test a React application that makes network requests. This is a very common use case. Let's run the app npm run dev. So the code base is exactly where we left it during the last session. And I had explained that I have this application with several screens. And if we open the screen with the fetch, um, so it's basically a button. Let me zoom in a little bit and open the DevTools, the network tab. Okay, so I have a button here, and when I click on it, I make this request to an endpoint greeting, blah blah blah. It's an endpoint that basically returns half the time a success message and half the time it fails with a 500 error with the message. So if it fails, the component displays a text here to the user that the fetch failed and gives them a chance to load the greeting again from the server. So the button is still active and I can click it again. And this time we see that the network request was successful and we got back the message greeting, hello world. And this message that we got from the server is what we display here in a H1 tag. And the button now says okay, and it's disabled. I can no longer click on it. So this is basically how the app works. Let's have a look at the code. So in the source folder, I have screens and I have fetch.tsx. Yeah, so whenever I read a React component, I always look for the default export that is exporting the component and just go through it top to bottom. So basically we have use reducer hook. Yeah, so you're using a reducer. So our reducer will have the reducer function and an initial state. So if you just go up to the top, we have in our state an object with two properties, an error and the greeting, and they are both null in the beginning. And then we have our greeting reducer, and it's yeah, so a reducer function basically has some state and receives some action, and depending on the action that it receives, it returns a different version of the state. So we have a switch statement, and we are switching on the type in the action payload. And if it's success, then the error remains null, and we return whatever greeting was in the action of the payload. If the type is error, then the error property is updated with the error in the payload, and the greeting is null in this case. And if we don't match any of these two types, we just return an empty with the original state. So we'll have error and greeting back from our reducer, and we destructure them here, error and greeting. And our reducer has a dispatch method that allows us to dispatch different actions. And then we have a state variable to check whether the button has been clicked or not. We have a function here, fetch greeting. I will collapse it and come back to it afterwards. So depending on this Boolean variable, if the button has been clicked, the button text that we show is okay. Otherwise, we show load greeting. And then let's have a look at our JSX. So rendering a button. On click of the button, we call this fetch greeting function, which we shall check in a short while. Once the button is clicked, we disable this button of ours, and we display the button text in here. If you have a greeting from our reducer, we display a H1 with the greeting. And if you have an error, we display a paragraph that says failed to fetch. So let's check the fetch greeting function. So it's an async function because we are making a request to the server, and we're using a library called Reactjs, which we've imported at the top of our component, and it's installed in the project. So you're basically awaiting a GET request. So Reactjs would get, and this is TypeScript stuff. We expect a response that has a greeting property, and we're making a request to this endpoint. And with the response, we destructure out the data. And in our try catch, we are in a try catch block. So if everything goes successfully, we'll dispatch a Redux with the action of type success, and we pass in the greeting as the payload. And then we set our button to be clicked. And then if we have an error, we catch the error, and we're dispatching Redux action of type error, and we pass in the error message if we can be able to obtain it. So if error is an instance of error, we have a message in the error object. Otherwise, we just stringify whatever error message we have and return it back. So this is our basic component. Uses a reducer and just displays different parts of the UI depending on the state. So we've seen how it works. Let's write a test for it. So in the same folder, I'll make a new file and I'll call it fetch.tests.tsx. Okay, so we have our test file, and we can start writing our tests. So I will import test from the test, and we make our test loads and displays data. And then we have a second argument as a function. So in our test, we want to use React testing library to render our component. So I will import render from React testing library, and we'll render our fetch components, which I will import from the fetch file right here. And yeah, we have a component. So the more you write tests, the more it becomes clear what you actually need to do. So basically what we want to do in our application is go and click on this button that says load greeting, and then make assertions after we wait for some time. So after you make a greeting, because it's asynchronous, we have to wait until we either see this message or we see hello world from the server. So I'll just write that, and whenever you want to perform an action in our tests, we fire event. So I will import fire event from React testing library, and the event I want to fire is a click event. And then I need to select the thing I need to click on. So I'll use screen also from React testing library, and I'll say get by text load greeting. So yeah, the button says load greeting. You can always use the playground, of course, to find these selectors. So what we want to do in our test is we are firing an event that is going to go to a server somewhere. So this operation is going to be synchronous. So our test has to wait for the data to come back. So what we'll do is we will convert this function into an async function so that we can await the result that comes back from the server. So React testing library has a function called wait for, and it allows you to wait for certain things in your application. So in this case, we want to wait for something to happen on the UI. So we know that if I click on this greeting, I will see a heading on the page which has the text hello world or whatever text that the server returns. So I can wait for an element that is a heading. So I'll say I want to wait for text a function, and I'll say I want to wait for screen dot get by role heading. So I am clicking the button, and then because I know that this is going to the server, I'm waiting for the document to have this thing. So this thing to be present in the document somewhere. So this test usually stays for like 5 minutes, if I'm not wrong. There's a timeout in React testing library that it will wait for this to happen. And if it doesn't happen in this timeline, then the test will fail. Otherwise, if it happens in this time span, then your test is successful and you can go on and do some more assertions. So basically, we want to, after waiting, we want to make some assertions. So I'll import expect comes from vtest. We have expect here, and I'll say I want the heading to have text content of hello world, and I will just use a regex because yeah, it's easier to match with a regex, which is case insensitive. Then you don't have to worry about the capitalization of the text that you are asserting against. So I want to assert that there's a heading in the page and it has a text of hello world. And also something else we see on the page is that the button on the page is disabled. So I can make another assertion and say expect screen.get by role button to be disabled. So yeah, the button on the page should be disabled. So that's our test. We have our test there, and I will open a new terminal. And remember, we had a script to run our tests in watch mode, test watch. So I'll just run npm run test watch. Okay, so our test runs. You can see it takes a lot of time more than the first test because it's actually waiting for the request to be made to the server before it can get the output. And our test is passing, so it means we sent a request. When we clicked on this button, we got back the text hello world, and the button is disabled. So if I save this file again, the watch will watch for the test and will run the test again. And as I said in the beginning, my server half the time returns a success message and half the time returns an error message. So as we can see right now, the API response was not successful, so the test is failing. And yeah, this is not good. If our tests are dependent on some server somewhere out there, then they're not deterministic, and you cannot rely on tests that pass half the time and fail half the time. So we have to introduce a concept that is used in testing, which makes sure that we can safely run these tests, and every time we can be sure that our tests will pass, and we don't actually hit the real server out there. So what we're going to do is something that is called mocking, and basically a mock object is a fake object that mimics the behavior of a certain object, but it mimics it in a controlled way. So I'm able to control how my mock object will respond given certain parameters that I provide to it. So mocking is used a lot in testing, and it's basically means that you are creating a fake version of an external resource, like let's say our API endpoint in this case, that can stand in place of the real one, so that your tests don't actually use the real API endpoint. And this will help you in your test. Your test will run more faster because they'll not have to wait for the API call to be made. And also your test will be more reliable and predictable. So you'll be sure that something is not going to fail because the server is down and nothing has changed in your code base. So we basically need a fake version of our external API service. So mocking is a very huge topic in testing, and we also have something else called stubbing. So you can also create a stub, and a stub, the difference between a mock and a stub is that a stub only mocks the behavior of an individual object, so an individual behavior of a certain module, not the whole thing. But then in mocking, you can mock the whole thing. So in this case, we want to mock our whole server and have a fake version of the endpoint so that we call them and they are deterministic in our tests. So there are very many ways of mocking. I will not go into mocking as a topic today. I will just show the recommended way to mock when you're using React testing library. And it's this library called MSW. So MSW is a short form for mock service worker. And yeah, from the homepage here, it's an API mocking of the next generation. So how MSW works is it mocks API endpoints by intercepting requests on the network level. It uses something called service workers. So service workers work in the browser, and they sit between your browser and the internet. So you can tell them to respond to an API request in a certain way. Service workers don't work in Node, but MSW has figured out a way of making sure that you get the same experience even if you're running this from Node, which is what we're going to use today. So we will set up MSW and set up our mocking for our endpoint so that we can avoid hitting our real backend in this case. So I will install it by copying this. I will open a new terminal here. And we install it as a dev dependency because we only want to use it in our tests. So if you look at the package JSON, yeah, MSW should appear here. Yeah, so we have MSW and we're good to go. So the next thing we need to do is define the mocks. So as I said before, like a mock is a fake object, a simulated object. So we want to simulate here our backend API, and we'll create a mock. So I'll create a file in the tests folder, and I'll call it handler. So we want to create a handler for the REST API that we are using. MSW allows you to mock REST APIs and also mock GraphQL APIs. So in our case today, we have a REST API, so that's what we'll mock. So I'll create a file called mocks/handlers.ts. So in this file, I'm going to import REST, and this comes from MSW. So basically, what REST does is it allows you to intercept all the REST operations like get, post, put, delete, anything that you want to fake out. So we export a variable called handlers that we'll use later. And handlers is basically an array of all the mocks that you have. So how you define a mock is using REST. So I'll say REST.get. And then the first argument is the path or the URL that you want to mock. So in this case, I will just go to my fetch component and pick the API endpoint that we want to mock out. So we don't want to call this endpoint. We want MSW, whenever our code calls this endpoint, instead of calling this endpoint, it responds with our own version of the response that we want. So this is basically if you've written Express or looked at any code from a backend code setup, we have a request, response, and context objects in this. We'll not use request. Request is what you're sending out. We're not going to use request in our example today. So I will, just hold the place there with an underscore because I'm not planning to use it. But we will use the response. So what we're going to do inside here is return our response. And response. And in our response, we can choose to respond with a certain status code and a certain JSON payload, the same way that the server will do. So what we want to respond with right now, I'll say a context dot status. I want to respond with the success status, and the second argument I say context dot JSON, and I say whatever JSON payload I want to respond to. So this should match what your API is doing. So here you can see we have a 200 status code, and the payload is this JSON object. So I'm just mocking it out to respond in the same way. And you can add here as many handlers as you have that you need to mock. But for our demo today, we only have this one handler, so we'll only mock this. Next, we will configure our request mocking server. So now we want to make our own server that will handle this. Let me just copy this. So we're making a file in the mocks folder called server.ts, and this will be our mock server instead of hitting our backend server. So what we're doing is we're importing setup server from MSW node. MSW also has a browser API. And then we're importing the handlers from our handlers file, and we are saying setup server, and we spread handlers is an array. So we spread all the handlers in our server, and we export this server function here. What you want to do next is configure our request mocking. So we have a server set up. Now we want to tell vtest to start this server whenever our tests start, and then listen to API requests that are going out from our components whenever we run the tests, and then close this mock server after all the tests have run. So the way we do this is in our setup TS. Remember, we had a file called setup TS where we set up all the stuff regarding our tests. What we'll do is we will, this is imported twice. So we'll use hooks from vtest. So vtest provides some hooks which can allow you to jump into a certain lifecycle part of your test. So we have what we call after all, after each, and before all. So before all is a function that will run before all your tests start. So whenever you run the test script, right now we see here that we have two tests. Like we have 4 tests in the 2 test files. So before all these tests run, whatever function you wrap inside the before all will run before that. And then after all, we run after all the tests are finished running. You use it for cleaning up anything that you have set up in your test. After each runs after each test. So this is a test. This is one test. And we can have another test here. So after each will run after each test. And we also have before each. So depending on what you want to do, you can use these hooks to tell vtest, please run this code at this particular time during the test lifecycle. And then we import our server that we've created here, the mock server. So what we want to do is say before all the tests, run this function. So the function is server, the mock server dot listen. We're telling our server to start listening to requests to the endpoints that we've set. And then we're passing a flag here that says if our application ever makes a request to an endpoint that we have not defined in our handlers, how should MSW react to that? So we are saying here it should show an error. It should tell us, hey, your component is trying to make a request to this endpoint and you haven't mocked it. So please just know that this one is going to the server that is being hit and it's not a mock anymore. And then after each test, we want to reset our handlers. If we have a handler set up like this, the first test runs, it uses it for whatever reason. It can be maybe a post request and it's changing some data. we just want to make sure that we are resetting all the handlers so that each test runs against all the handlers that we've defined in the way that we've defined them. And then after all the tests have run, we want to close our server. So we open it when all tests start, and we close it when all the tests are finished. So this is how we will set up our tests, and that's it. We don't need to do anything else. So right now, if I just kill my tests and run them again, so we see that our test passes, the test that we ran. And what happens is that our endpoint was not called. The real backend wasn't called. What was called was our fake handler. It was called here, and it came in and returned this text. So if you want to know that our handler is working, we can say here, hello world new, for example. So when our test runs, the handler will return hello world new instead of hello world. And we can see now, if I run my test again, it was expecting hello world. Now it's receiving hello world new because my backend is actually here. This is what is responding to my component when my component makes an Axios request. So you can mock your server and do whatever you want here, and your tests won't change. They won't know that you're not actually hitting your real server. And this is recommended way so that you don't hit your server. So assume you're making an application that allows people to pay via M-Pesa, and you have this function that goes to M-Pesa and charges the customer. You don't want your test to be doing that every time and costing you money and stuff like this. So that's why mocking is important. So let's just briefly look at an example of what if I wanted to mock my API and pretend that the request failed. How can I do that? So I will paste this example and explain it through. Okay, so first thing, we want to do a custom handler inside our test. So I will import REST from MSW and our server from our mock server. And what I do is I have a test here that handles server errors, and it's an async function as well because we're going to hit a server. And inside here, I can make a mock that will return a failed request. So I'll say server.use. This allows me to set a mock that will run only in this test. And then I'll say rest.get. So I'm mocking the get request of my API endpoint. And if this API is hit by this specific test, not any other test, but only this one, I will respond with a status of 500 and a JSON payload of a message, we have an error. And then I can write my test the same way. I can say render my fetch component, and then fire an event. So click on the load greeting button, wait for us to have an alert on the page. Remember, we have a element here. So if I load this and I get an error, if I inspect this element, inspect, it's a paragraph role alert. So I say here, get by role alert. And then I say expect the alert to have text failed to fetch, and expect the button not to be disabled. So this is a test that tests that what happens if my request fails. And I'm sure that I'll only hit this when it fails because I'm mocking that the request is failing at this point. So if I save this, yeah, and I get the 5th test passing. Just to be sure, it's always nice to make sure that your test is failing. So I just try to make it fail, and I see actually that, yeah, the text is failed to fetch, and my test is checking for the wrong thing. So this is how you would test a component that makes API requests, and basically making use of MSW to make our testing to be nice and seamless by allowing us to mock our servers. So last week, this is what I aimed to cover. I had planned to cover this up to here, but since the bit that was remaining was not so long, and someone in last session asked me a question about how to test an application that uses Redux, I decided to add one more example, which I'm going to go through now briefly, how to test a React application that uses Redux. So let's, oh wait, let me check. I see, I think I have a question. Can you use MSW with Jest? Yes, you can use MSW with Jest. You can use MSW with Cypress, with Playwright. It doesn't, it's not tied to any specific library. Cool. Yeah. So, but that's nice. If someone has a question, you can just ask us. I keep going. Cool. So let's look at our last example briefly. How to test a React application that uses Redux. It's been a long time since I used Redux, but I quickly went to the Redux docs and made a small example with their dummy example. And my aim is just to show how to write tests for this function. So I open the Redux example. So yeah, it's a component that displays the title counter, and it has two buttons. And if I click decrement, decrements the counter by 1, increment increments a counter by 1, and that's basically it. The only difference is that it uses Redux instead of like React state. So let's have a look at the code. Going to the Redux, and yeah, Redux has a lot of things going around, and let's see. Let's start from our index.tsx file. So I have a basic component, and from React Redux library, I'm getting the provider and wrapping my component in a provider. That's what you do for Redux, so that you have the store accessible to all your components. And for the provider, you have to pass in a store. So let's have a look at the store. So we have our store here, and we're using the method configure store from Redux toolkit to set up a store with one reducer. So our store has a reducer, and the reducer is called counter. And the logic for our reducer is living in this counter slice component, which we shall look at in a short while. Then I export the reducer, and then I have some types for TypeScript stuff. Yeah. So let's check out the reducer, and basically have our state. The shape of our state is an object that has a property value, and the initial state starts at 0. The value starts at 0. And then we have this method create slice from Redux toolkit that allows you to create a reducer with its actions, and you can export them straight from your slice. So I call create slice. I name my slice counter. I pass in the initial state with the value of 0. And then I create some reducers for my slice. And I have two reducers. I have increment. So increment receives a state, and I update the value of the state, the value property in the state, by increasing it by 1. So remember, Redux, your reducers should be, what is the word? They should not mutate the value, but Redux toolkit uses a library called ima in the back internally that allows you to mutate the value, but ima will make sure that it doesn't mutate the final value. So I have a decrement reducer as well that reduces the value by 1, and that's basically it. And then from the slice, I pick my actions and export the two actions, increment and decrement, and I export the reducer as well to use in the store. So I have my reducer, I put it in the store here, I create my store, and with the store, I pass it into the provider, and the provider renders this reducer counter. So that's my application. So if you check reducer counter, we basically have from this file called hooks. This is basically because of TypeScript. I make so we have use dispatch and use selector from React Redux, but I want to type them, so I provide types and I return my custom functions, use app dispatch and use app selector, which I use in the app instead of use selector and use dispatch. If you're not using TypeScript, you won't need this part. So from the selector, I can get my state and select the counter value from the state, and that's my count. And in an H2 tag down here with an array label of count, I display the count. And then I have from use dispatch, I get my dispatch function, and I have two buttons. So the first button, when you click on it, I dispatch an action, and the action is decrement, which we import from our counter slice. And on the next button, when you click on it, we dispatch an action. And in this case, we dispatch an action called decrement, no increment. Yeah, so basically, this is how the app looks like. It's a simple app, and let's write some tests for it. Okay, so in my Redux folder, I'll create a new file, Redux counter.test.tsx. And yeah, the same dance here. We import test from vtest, and we want to say when the increment button is clicked, we want to assert that then the count is increased. So we will make our function here. Okay, so what we want to do first is render our application. So I will import render from React testing library, and I will render the Redux counter. And so we import this from Redux counter. So remember, like it's usually act, we're following act, arrange, and then now we have to do the clicking of the button. So our button has a text of increment, so we can select it by the text. And because we want to click on it, we call a fire event. So fire event dot click, and we want to call screen import. I am importing these libraries at the top. So screen.get by text increment, and instead of using the word increment, I will use a regex so that, yeah, I don't care about the capitalization. So I want to click on a button, the increment button, and now I can make my assertions. So yeah, if I click on this button, I have a the auto completions that you see here. They are from GitHub Copilot, so I use them. So I want to get this element, and this element we gave it area label of count, so we can select it by no, GitHub Copilot is wrong. This is label text. So it has an array label, so we can say get by label text, and then the array label is count, and we have it. We expect it to have the text content of 1. So this application loads, and our initial count is 0, and we press increment, and we expect this is 1. So this is our test, and I will save this. And we see a very humongous error on our console. I'll just clear this and run this again because I want to scroll to the top. Okay, so the error is could not find React Redux context value. Please ensure the component is wrapped in a provider. So we know that to have access to Redux actions and the state from the Redux store in our component, we have to make sure that our component is wrapped in the provider. But our test, React testing library, is complaining that our component is just rendered without being wrapped in a provider. So if you're writing tests and testing an app that uses Redux, all you need to do is also make sure that you wrap a component in a provider. So I'll just import a provider from React Redux and wrap this component like this in a provider. And our provider needs a store, so pass in a store, and we pass in our store from our application, which I import from the store file. So basic wrapping in the provider, I run the test again, clear my console, run the test again, and my tests pass. This is all you need to do to make your application testable if you're using Redux. Just make sure you wrap it in any provider that the application needs. So in our case, the application needs the Redux provider and it needs access to the store. We also do the same thing in our tests. We wrap it and give it access to the store. And this is, all you need to do to test Redux. So basically what we're doing here is that we are testing our application. So we are testing the Redux counter, of course, by rendering it, but we're also testing the store because this was set up and the store was 0 at the beginning. And when you assert that it's 1 on the page, it means our store was accessed and the reducer was called. And we're actually testing everything, like that the store was well set and the actions and the reducers, all of them worked fine, and that the component is just using them in the correct way. So we are in this case writing an integration test where we are testing both our component and the Redux store, which is really nice. So focus on testing what the user will see. The user will see a button, will click on it, will see a value change. They don't know if you're using Redux or React hooks. If I was to change this component and use use state inside here, as long as the functionality is the same, my test will still pass. And this gives me a lot of confidence in my application. So while this is good, you might find yourself doing this a lot of times. And sometimes you also want to test a component and start at a specific state. So let's just do an example here. I'll just copy all this test and write another one at the bottom. And I'm going to do the same exact test. But the difference here, the thing I want to show in this second test is that what if you had a custom initial state in your store? So with custom initial state, something like this. So we know that we are passing the store to our test over here, and the counter in the store is the initial one, which is always 0. What if you wanted to pass our own custom store instead of this one? So I will just rename this to custom store, and we can make a custom store at the top here. So I'll say const custom store. In this example, it might look like unnecessary doing this, but imagine you have a huge application where somebody has to click a lot of buttons before they get into a certain state, and you want to just write test for that state. So instead of like clicking all the buttons everywhere, you can just start your application with a certain custom store, which has a certain state already set, and make assertions against that. For example, you can skip logging in and only set the credentials in the store and make assertions that a user can be able to do a certain activity. So what I'll do is I'll go into the store file, and we basically want to do this thing ourselves. So I'll just copy this configure store function and put it here. We're actually making our own store. So I will import configure store from Redux Toolkit, and I will import our slice from counter slice, and just put this in online. So we have our store, and when it's like this is basically our store as we have it. But what we want to do is we want to be able to have some preloaded state in our store. So I can make, instead of using my default in the slice, instead of using my initial state, which has a value of 0, I can preload a state where the counter has a value of, let's say, 5 already. Yeah. So I'm creating a custom store where my state starts at 5. So if I render my component now, I fire the event increment, I expect my count to have text of 6. I will not change it first. I will run the test first to see it failing. So it says expected element to have text content 1, but received 6. So yeah, change it to 6, and my test passes. So I have skipped all the steps that needed to bring me to this state, and I can just like initialize my state into a certain place and write assertions against it from that point. So you can, yeah, like do whatever you want with your component. What React testing library allows you to do is just to wrap your component into providers that you have and render it, and everything else will work exactly the same as in all the other tests that don't use Redux. So you can see that we are actually duplicating this a lot in our tests. It might be nice to improve our code base a little. And also, assume we had, for example, this title here, assume it was coming from a prop. So if we had a heading prop instead of hard coding it, and then we'll have props in our component now. So I can say the heading, and if you don't provide a heading, it uses Redux counter by default. Yeah, because I'm using TypeScript, I will just add some types here. Okay, so I've changed my component so that now it receives an argument that's the heading. And yeah, if I come here now, I see it says Redux counter, which means in my tests, I can pass a heading. So whenever you render a component, I will use this second one. Whenever you render a component, you get some values back from this render function, and one of them is called re-render. And re-render allows you to re-render your component again. So what I'll do is, after I finish my test, I will re-render my component. And to re-render your component, you provide exactly the same thing as you do to render. So I have to copy this and provide it here. And this will render my component, and I can pass in a different heading, new heading, to my component. And if I come here and say, for example, screen.debug, I should be able to see new heading. So my component now renders the H2 with a new heading. But the point I wanted to show is that we are carrying this provider thing everywhere we go, and it's just becoming too much. So we can improve this a little bit, and React testing library provides options for the render method, and one of them is called wrapper. So I can pass a second object here, and I can say wrapper, and I can pass a component here. So I'll create a component called wrapper. I'll just make a function top here. Function wrapper. And this allows you to provide anything you want to wrap your component with. So in this case, we are wrapping our component with our provider. So I'll just pick this and return it from this component. And whatever you pass in as children here, children, it's what we pass to this wrapper. So, okay, TypeScript is complaining. I will fix the types, but just so that I don't distract anyone, I will do ts no check at the top here so that TypeScript stops checking my file just for now. I will fix it. And then Now, because we have a wrapper component here, we can remove this wrapper here. And the benefit of wrapping a component here is that the re-render is also wrapped for you. So I can also remove this here. And now my test passes. The second Redux counter already has the provider wrapped in it because I provided the wrapper function in the top element here. So this is nice, and yeah, it looks much better to have this. But yeah, the first test also might benefit from this change. So why don't we make this a utility that we can reuse yeah, for our test? So I'll come to the top of my file here and do another function, and I'll call it custom render. So I want to make my own render function which already wraps Redux, and then I just use custom render instead of render. So I want to have the same interface as render. And if you look at this bubble here, so render receives the first argument is the UI that we want to render, the components. And then the second one is some render options. So yeah, whatever options, like wrapper is one of the render options. So our custom render will also receive a UI as the first element and some render options as the second element. And what we do here is basically returning the render from React testing library, and we pass in the parameters. So nothing has changed here, but now I can copy this and replace my render with a custom render also here. Yeah, so now I'm not using the custom render anymore. Maybe even what might be good might be if I rename this render as React testing library render, then I use it here, and I can just call this render instead. So I will rename this to render. So now render is my custom function that just calls render right now. It doesn't do anything yeah, additional. But what I want to do is pick this wrapper function that we had here. So I'll cut this and put it inside my render function. So now we have yeah, a function, a wrapper that is inside here. And then we'll come back and say what we are doing here. We were saying render, we pass our UI, and then we pass our wrapper. So what I'll do is I'll do the same thing. So we want to, so like we want to create the same functionality. Wrapper is part of render options right now. So what I'll do is I will remove it and create an object and call wrapper myself, and then pass in our wrapper component, and then I will spread all the other render options afterwards. So now I'm rendering my UI, passing in the wrapper component, which is this, which is wrapping our Redux provider, and then passing in all the other render options that we need. So now I can remove wrapper from here. Yeah, I can remove wrapper from this function and save this. I'll just remove this debug because it's noisy. Let's see what message you get. Yeah, so it says custom store is not defined. Okay. Yeah, we are in the middle of refactoring. So yeah, we're using custom store, and we defined it down here. So what I will do is I will first just put this back to the default store. And then if I save my file now, I have, yeah, re-render is not available. and it's because we don't return from our function. Next, we expect 2, get 6. Okay, yeah, this test is wrong now. 2. I just want to make this pass so that, yeah, we are good. So we've just changed our render from the React testing library render to our custom render that already includes Redux. So in our first test, we can also remove the provider and just call render like that. Yeah, so our tests are passing, and we have our render. But in our second test, remember, we were able to pass a custom store. So this is nice. We should keep this functionality. So let's move this into our utility as well. So I'll come back to the top, and after my wrapper component, my wrapper function, I will put this store here. I'll rename it to store, and I will delete the store that we're importing at the top. So now we have our store where we configure the store, and we pass in some preloaded state. So what I want to do is, instead of hard coding this preloaded state here, I want to allow the user to pass in the state themselves. So these render options are from React testing library. So I'll just spread them here, and I will add preloaded state. So our user can provide their own state. And if they provide their own state, I will use that state here instead. So if they give me some state in this render, I will just pass it into our store function. So now if we go back to our second test, now I can give a second argument and just give my preloaded state. So I give a preloaded state. And now if I save this again, my second test should be failing, because now it should be 6 again, because I preloaded the state of 5, and now should be 6. So save this, run my tests, and I have a preloaded state, and I pass it in as a second argument. Cannot destructure property preloaded state of undefined as it's undefined. Okay. So this error comes from the first test. This first test doesn't pass any preloaded state. So to avoid the error, we come to our function at the top and initialize it to an empty object. So if we don't pass any state, we use an empty object. If you pass, we use it. So now our tests are passing again. And this looks much better, but we can also allow a user to pass in their own store instead of using our default store here. So I'll just cut this and put it as an argument in my function here, and remove the const. So now a user can pass in a preloaded state or their own custom store, or just pass in render options for React testing library, or pass nothing. And then we make sure we wrap the component in Redux and export the testing library component. So our tests are much cleaner now. I just say render Redux counter without caring about wrapping it in Redux. I can render the counter with some state in the beginning. I can re-render the counter, and all this time Redux is nicely wrapped in the component. Yeah, and then like one last step is I would want to use this for all the other tests as well. So it will make sense to move this into its own function, where I can later import it from that function and use it in other tests. So I'll just cut this and go to my tests folder and make a new file, and I'll call it testutils.ts. Yes, and I'll paste this in here. Then I'll pick my inputs. Yeah, just pick all of this and move them over here. So we're not using VS Code has this organize imports, and I can organize my inputs. I should import this from the correct place. This file should be JSX, I think, because I'm using JSX. Yeah. Okay, my imports are not working, so import. Where's the counter slice from here? We go back to test, back to mock, and then to Redux. Okay. No. Yeah, one step up, and then go to source, and we go to screens, and we go to Redux and counter slice. Okay. Yeah, so what we want to do here is export everything from React testing library so that we can just import it from this package, and also export our render method that we've just defined. Yeah, this render method. Cool. So now in our test, instead of using render from React testing library, we can import render from import render from our file. So the file is at go back and go to tests and test utils. Okay. And I can get rid of this no check now because there's no more TypeScript in this file. Okay, so this is running fine. And now in any other test file, we can just import render from test utils, and we get our render, which is already wrapped in a provider, and everything working fine in there. So just as a last step, it's not necessary, but I will fix my TypeScript errors. So children is React node. Our UI is React element. Our preloaded state, I will make a type for this type. Call it custom render options. So we have a preloaded state, and there's a type called preloaded state from Redux toolkit, and we pass in our root state. So root state is just the type from our store.getState in our store.ts file. Then the next thing is our store, and this is optional, and it's a store. So store comes also from Redux toolkit, and we pass in our root state. And lastly, we have render options. Okay, we put them outside. So we have our render options. We don't want the wrapper to be in there, so we will omit from the render options. Render options comes from React testing library, and we don't want the wrapper in there. Now I can take my type and assign it to my arguments here. It's not necessarily TypeScript if you are not using TypeScript, but the benefit of having TypeScript is something like this. So if I come here and I pass 5 as a number, TypeScript will tell me that, yeah, 5 is not a number, which is wrong. If I run my test right now, because we are in JavaScript, JavaScript will take 5 and add 1 to 5 and get 51 as a string, which is an error. So remember when you started, we said there's the testing pyramid, and TypeScript is one of testing tools. It allows you to do static testing. So it already allowed me to see that I have an error in my code before I ran it. But yeah, you don't need to have it. So basically, this is how you test Redux in your applications. And I'm hoping that I have answered the question from last week about Redux. Cool. So that is the end of my presentation of how to test your React applications using vtest and testing library React. And yeah, does anyone have any comments or any questions?
Hi, Sande.
Hi.
Anthony.
Yes.
That was a good presentation.
Thanks.
So I am a beginner. Okay, I'm starting out to learn testing React applications. So I wanted to ask, when you're doing unit tests, which are some of the principles or rather guidelines that are supposed to guide you in terms of what are you supposed to test? Are you supposed to like test the functionality, how a component renders? What are the guiding principles?
Yeah, so unit tests are basically like the smallest bits of tests you can do. You're basically testing a single function or a single component if you're in React in this case. And you're normally testing what the user will do with that component. So if you saw in my examples, for example, I had components which had buttons, and if these buttons were clicked, they will do some particular action. So this was the focus of my test. You definitely mostly never want to test whether the component receives the correct props or whether the state variable was set. These are called implementation details, and the user normally doesn't care about whether you're using 2 props or 3 state variables, and you should avoid testing anything that the user won't see. So just look at your component when it's rendered on the page. How do you interact with it? Do you click on it? Do you type inside of it? Do you drag it and drop it somewhere else? Do you right-click it? And all these events, you can fire them with a React testing library, and then you can make assertions. What happens if this action is done? So the principle that I showed last week is called ACT. No, it's called the AAA, arrange, act, and assert. So arrange is setting up the component for testing. This normally involves wrapping it in a render function, wrapping it in a provider, passing all the props that you need so that you set it up nicely for testing. And then we have act, where you perform an action on the component. You either click on it, drag it, type inside an input, right click, all those are actions. And then you make assertions. So you expect something to be in the document, to have some text, to not exist. Yeah, so this should be the main goal that you aim for. Look at the component, see what the user will do with that component, and then write tests to test that that thing is working well. Did that answer the question?
Yes, that was well elaborated. Thank you. And is it possible to get the video, the recorded version of the previous session that you had?
Yes, the previous session is uploaded on YouTube. Let me get the link and post it here.
Yeah, we can also repost it in the group so that you can also check it later, or anyone else who still wants it. Yeah, but it was posted, but we can do it again also.
Yeah. So for starters, the link is here in the group and in the Meet, Google Meet chat, and then I'll also post it in the group.
Okay, thank you.
You're welcome. I'll also post it in the Telegram group. Cool. So yeah, I'm hoping that most of you yeah, start writing a lot more tests than you do right now. Testing is always nice and fun. There's a lot more to be covered. Maybe in future, yeah, I might do this again. Topics like mocking, it's a huge topic. We also have a whole category of tests called end-to-end tests that we didn't touch anything about. Yeah, but the principles are the same. And the more you write tests, the more you encounter all these situations, and the more you gain, yeah, like confidence and knowledge in how to test your applications. Cool. Yeah, I know Rama can't say something. Maybe Stephanie, you can close up.
Yeah, okay. Thank you so much, Anthony. Is there anyone else left with a question before we close? Well, if not, thank you so much, Anthony. Thank you, everyone who came. As usual, Rama will put out the recording for this session as well. He'll share it in the group. So yeah, thank you so much, everyone. I think we can close here. So have a good evening.